Alright, in this question we are doing number 2 and plug and chug. Calculate the force of gravity on the same 1 kilogram mass if it were 6.4 times 10 to the 6 meters above the Earth's surface. That is, if it were 2 Earth radii from the Earth's center. What that's trying to say is essentially if the object were 2 radiuses away from the center of the Earth. If I were to draw a picture, I'd have a picture of the Earth right here. 1 Earth radii is this, and that's, I believe, 6.4 times 10 to the 6 meters. And here's the object. What if we raise that object to say maybe there is a really, really big mountain that were another 6.4 times 10 to the 6 meters above the Earth's surface? So in total, this distance would have to be 2 times 6.4 times 10 to the 6 meters from the center. So that'll be our new distance. Other than that, all of our other givens are the same. Our first mass is a 1 kilogram mass. And it really doesn't matter whether this is mass 1 or mass 2, they both get multiplied. Mass 2 in this case will be Earth's mass, which is 6 times 10 to the 24th kilograms. We have our distance, which is now 2 times 6.4 times 10 to the 6 meters. One thing we also have to know is that when we're calculating the force of gravity between two objects, it is big G times m1 times m2 divided by d squared. In that case, we'll need the value of G, which is 6.67 times 10 to the minus 11 Newton meters squared over kilograms squared. From there, all we need to do is plug in all our numbers. F is equal to 6.67 times 10 to the minus 11 Newton meters squared over kilograms squared times 1 kilogram times 6 times 10 to the 24th kilograms divided by 2 times 6.4 times 10 to the 6 meters squared. When plugging this into the calculator, it's really not hard to plug these in here, but you'll have to make sure you have the parentheses in the correct place when plugging it into the calculator. If you plug it into the calculator and look for a final answer, the final correct answer for number 2 is around 2.45 newtons. And if you compare this with the answer to number 1, which is 9.77, this is about 1/4 of the force. So if you're increasing the distance by 2, you're decreasing the force by 4. That's the inverse square law, which I will cover in another video.